Solve problem on static force analysis in IC engine by analytical method. Let us understand some important formulas related to static force analysis in IC engine mechanism. In IC engine mechanism, there are two types of engines. First, horizontal engine and second, vertical engine. We will consider the horizontal engine. If we observe this diagram, here OB is the crank of radius r. It rotates through an angle theta from this inner dead center in clockwise direction. Then this AB is the connecting rod of length L. Now when we are going to consider the static force analysis, then we should not consider the effect of inertia force due to the mass of the connecting rod. Now this connecting rod is connected to the piston at this point A. Now here this is the cylinder and piston arrangement. This cylinder is having diameter capital D and this piston rod is having diameter small d. Now we will understand the formula for the piston effort, that is capital F. So what is this piston effort? That is the net force applied on the piston. Now if we understand this diagram, then inside the cylinder there is the gas pressure acting on this piston. So this pressure is P1, and on the other side of piston there is the atmospheric air, and this pressure is also acts but in opposite direction. So this pressure we will consider as a pressure P2. Now the area of exposure of this gas on this piston is known as area A1. So how to calculate this area A1? So A1 is equal to pi by 4 d square. Now how to calculate the area of exposure of the atmospheric air on the other side of the piston? So for that we will first calculate area of this piston rod. So this area is known as small a, which is equal to pi by 4 small d square. So A2 is equal to A1 minus A. So this we have to subtract the small area of the piston rod. Now we know what is P1 A1 as well as P2 A2. So how to calculate force due to gas pressure? So force due to gas pressure, P is equal to P1 A1 minus P2 A2. Now remember, this force due to gas pressure is always greater than the atmospheric air pressure on the other side. Now we will move to the next force, force due to inertia. Now here this diagram shows that the crank rotates through an angle theta in the clockwise direction. So initially this point B is along this horizontal line, that is at this point. So when this crank rotates through an angle theta, at the same time the piston will move in the forward direction. So I will show the direction of the movement. So this is the direction of the movement of the piston. So the acceleration of the piston cylinder arrangement is also in the same direction. So because of this movement of the piston cylinder arrangement, there is the inertia force, and that we have to consider. So we know that the inertia means the resistance to the motion of the system. So this resistance applied in the opposite direction. So in the opposite direction to the acceleration, we will show this acceleration, that is the inertia, that is Fi. So this inertia force acts in the opposite direction. So how to calculate this Fi? So this Fi is equal to mass into acceleration. So what is the mass? The mass is that is nothing but mass of these reciprocating parts. So we have to consider Fi is equal to m into A. Now suppose there is the friction mentioned in the question. So due to friction, there is the friction force applied to the arrangement. So this friction force always acts in the opposite direction to the motion. So this motion is towards the right hand side direction. So friction force we have to consider in the opposite direction. So this is the friction force. So all these forces, that is, first is the force due to gas pressure Fp, then second one inertia force as well as friction force, we have to consider to calculate the piston effort F. So what is the formula? So F is equal to, now if we observe this force due to gas pressure, that is Fp is having the same direction. So direction of Fp is in the same direction of the motion of this piston cylinder arrangement. So F is equal to this Fp minus Fi minus Ff. So this is the formula that we have to consider the calculate F. Now this Fp we will put the value. So Fp is nothing but P1A1 minus P2A2. Then minus Fi. So what is this Fi? That is minus m into a. Now for this acceleration, so suppose Ff is not mentioned in the question, then we have to consider here 0. So again we will simplify this F into I, that is the inertia force. So how to simplify this? So we can rewrite ma as minus, in the bracket we will replace this as mr omega square cos theta plus cos of 2 theta by n. So this is the final formula to calculate this piston effort, that is F. Now we will calculate force along connecting rod. So this is the connecting rod, and this force along connecting rod is also known as net force on gudgeon pin. So this gudgeon pin is placed at this point A, that is the point of contact with this piston and this connecting rod. So how to calculate this? Now if we observe the net effort of the piston, that is F, and this F is acting in this horizontal direction towards the right hand side. Now this Fc is along this connecting rod and direction is towards this gudgeon pin. Now we will resolve this Fc into horizontal component as well as vertical component. So this connecting rod is making an angle phi with this horizontal lines. This horizontal line is the line of action of the movement of this piston cylinder arrangement. So how to resolve this? So I will resolve this horizontal direction. So what is its a value? So value of this component is Fc cos phi. Fc cos phi. Now we will resolve into vertical component, and vertical component value is Fc sin phi. Now if we compare this, then F is equal to, because F and Fc cos phi are in opposite direction, so I can write here F is equal to Fc cos phi. So how we can find out this value of Fc? So Fc is equal to F divided by cos phi. So this is the formula to calculate the force along connecting rod. Now we will move next, that is the normal reaction or thrust on the sides of the cylinder wall. So how to show that? So thrust on the sides of these cylinder wall. So these are the cylinder wall, and thrust is always acting in perpendicular direction. So here this is Fn, that is the normal reaction. Normal means perpendicular. Normal reaction or thrust on sides of cylinder wall, Fn is equal to. So this Fn and Fc sin phi are in opposite direction. So we can say that Fn is equal to Fc sin phi. So this is the formula to calculate Fn. Now we will move to the next formula, crank effort. It is also known as force applied at crank pin or torque about the crankshaft. So how to calculate this? Now this force along connecting rod is acting towards this gudgeon pin in the same way it is acting towards this crank pin. So this crank pin is at point B. So along the same line of connecting rod we have to show Fc, but in opposite direction. Now we have to resolve this Fc at this crank pin in the horizontal component and vertical component. So this is this components that we have to show for this FC. Now how to find out the value of this? Now if we observe this triangle OAB, then at this point O angle theta is made. Then at this point A angle phi is made. So what is the value of angle ABO? So in this triangle, this angle ABO is equal to 180 minus in the bracket theta plus phi. Now if we observe, this is the straight horizontal line, that is here this FC is getting resolved. So along this connecting rod, this is the straight line and here is one component, that is B to O. So this one side angle is known 180 minus theta plus phi. So remaining angle will be equal to theta plus phi. So now if we observe this component BO is making an angle of theta plus phi with FC. So we can write its a value of this component is FC cos of theta plus phi. And the remaining component, that is for this component we will write FC sin of theta plus phi. Now crank effort, that is the force applied at the crank pin, or we can say torque about this crankshaft, that is known as Ft, and this Ft is nothing but this component, that is component at this point B. So it is Fc sin of theta plus phi. Now thrust on bearing. So thrust on bearing is the second component and it is equal to Fc cos of theta plus phi. And so notation is Fr. So I will write here this as a Fr.
Given question, the length of crank and connecting rod of an engine are 200 mm and 1 meter respectively. The crank is rotating at 400 rpm when the crank has turned through 30 degrees from inner dead center. The difference of pressure between cover and piston rod is 0.4 Newton per millimeter square. If the mass of reciprocating parts is 100 kg and cylinder bore is 0.4 meter, calculate first inertia force, second piston effort, third thrust on sides of cylinder walls, fourth thrust in connecting rod, fourth crank effort, fifth turning moment.
Let us understand the given data. Length of the crank, that is value of R is equal to 200 mm is given. So standard unit is meter. So we have to convert this as R is equal to 0.2 meter. Now the length of connecting rod L is equal to 1 meter. It is mentioned in the question. Now the mass of reciprocating parts M is equal to 100 kg. Diameter of the cylinder bore capital T 0.4 meter. Now the speed of this crank is given N is equal to 400 rpm. Now it is mentioned that the crank rotates through an angle of 30 degrees from this inner dead center. So whenever inner dead center and outer dead center is mentioned in question, that means this is the question for the horizontal engine. So we have to mention here angle theta is equal to 30 degree. Now the pressure difference P1 minus P2 is also given and it is 0.4 Newton per millimeter square, but standard unit is Newton per meter square. So how to convert? So I will write here 0.4 into Newton divided by meter square. So we have to convert this millimeter into meter. So I have to write how to 1 millimeter, that means we have to write here 10 raised to minus 3 meter. So we have to take here as a square, that means 10 raised to minus 3 and outside the bracket there is square. So we will write here 0.4 divided by 10 raised to minus 6. So this 10 raised to minus 6 we can take this in the numerator. So 0.4 into 10 raised to 6 Newton per meter square. So this is the value for P1 minus P2. That is the pressure difference about this piston is given. Now the first question is, we have to calculate the inertia force. So inertia force Fi is equal to mass into acceleration. So m into a. So how we can resolve this a? That is r into omega square cos theta plus cos of 2 theta by n. Now we have to calculate omega. So what is this omega? Omega is the angular velocity of this crank. So how to calculate this? Because n is given. So omega is equal to 2 pi n by 60. That is 2 pi 400 by 60, which is equal to 41.89 radians per second. So this is the unit for omega. Now we will find out the value of n, because here in denominator n is there. So n is the obligatory ratio and it is L divided by R. So what is L? That is 1 and R is 0.2. So n obligatory ratio is equal to 5. Now we will put the value. So m is 100, R 0.2 multiplied by 41.89 square in the bracket cos 30 plus cos of 2 into 30. That means we have to take here cos of 60 divided by 5. So when we calculate this, then we will get the answer in Newton. So by multiplying with 10 raised to minus 3, we will convert it into kilonewton and it is 33.903 kilonewton. Second question, force due to gas pressure, that is Fp. So Fp is equal to P1A1 minus P2A2. So A2 is equal to A1 minus A. So this is the formula to calculate area A2. But here small a, that is the area of piston rod, or we can say diameter of the piston rod, is not mentioned. That means it is negligible and we have to consider as a 0. So A2 is equal to A1 minus 0. So A2 is equal to A1 and we will refer here as A. So we will consider instead of A1 and A2 as A. So what is the formula? Fp is equal to P1 minus P2 outside the bracket A. So here P1 minus P2 is directly given. That is the difference in between these pressures of the gas and atmospheric air, 0.4 into 10 raised to 6 and multiplied by area. So area, we have to take this, we have to consider this capital D 0.4. So pi by 4 into 0.4 squared, that is Fp is equal to 50.265 kilonewton. So answer we will get in Newton, but we have to convert it into kilonewton. Now piston effort. So we have to calculate piston effort. So we have already calculated inertia force. So we know that inertia force, that is Fi, always acts in the opposite direction of the motion. So motion of the piston is towards this right hand side direction. So this is the direction of this Fi. Then Fp, that is the gas pressure, it will act in the forward direction. And this Ff, that is the friction force, that will also act in the opposite direction, but it is not mentioned. So we will consider here as a 0. So F is equal to this Fp minus Fi minus Ff. So Fp is 50.265 minus 33.903. And answer, so both the values are in kilonewton. So piston effort F is equal to 16.36 kilonewton. Next question, thrust on sides of cylinder walls. So thrust on sides of cylinder walls, that is this normal reaction Fn, that we have to calculate. So we know that force along this connecting rod is Fc. Now we will resolve this force Fc towards this gudgeon pin into two components, horizontal component and vertical component. So the angle made by this connecting rod with this horizontal line is phi. So value of this horizontal component is Fc cos phi and this vertical component Fc sin phi. Now if we observe, this Fn and Fc sin phi are opposite to each other. So Fn is equal to Fc sin phi. So we don't know the value for this Fc. So how we can rewrite this Fc? Now if we observe this horizontal component Fc cos phi is equal to piston effort F. So we can write here F is equal to Fc cos phi. So Fc is equal to F divided by cos phi. So we will replace here Fc as a F divided by cos phi. So this value of f that we have already calculated. So this sin phi divided by cos phi is equal to tan phi. Now we don't know what is this angle phi, but the angle theta is mentioned in the question. Now if I draw here one perpendicular line through this point B and on this horizontal line, then here is BC. So because of this extra construction line BC, there are two triangles ABC, and here this point is O, that is CBO. Now from these two triangles we will find out the value of BC. So we can say that sin phi is equal to BC divided by AB, that is AB is nothing but L. So I will write sin phi is equal to BC divided by L. In the same way I will write sin theta is equal to BC divided by R. Now this BC is common. So BC is equal to sin phi into L, which is equal to BC is equal to sin theta into R. Now we know that L by R is the obligatory ratio, that is value of n. So L by R sin phi is equal to sin theta. So how to calculate value of sin phi? So sin phi is equal to sin theta by n. Now this value of n that we have already calculated, theta is equal to 30 degree, then we can calculate here value of phi. So sin phi is equal to sin 30 by phi, and that's why phi is equal to 5.74 degree. Now we can put here the value Fn is equal to value of f we have calculated earlier multiplied by tan of 5.74. So answer is 1.644 kilonewton. So we will get the answer in Newton, but we have to convert it into kilonewton. Fifth question, thrust on connecting rod. So thrust on connecting rod is Fc. So if we observe this diagram, we know that F is equal to Fc cos phi. So we can write here Fc is equal to F divided by cos phi, and that is 16.36. Now its a unit is in kilonewton divided by cos of 5.74. So answer is also in kilonewton, 16.44 kilonewton. Now next question, crank effort. So crank effort is Ft, and it is in this component of Fc is known as Ft. So how to calculate this Ft? So this value of this component Fc, we have to resolve this Fc into two components. So this component and here is one component. So the angle made by this component with Fc is theta plus phi. So its value is Fc cos theta plus phi, and the remaining component Fc sin theta plus phi. So this is nothing but Ft. So Ft is equal to Fc sin theta plus phi. So 16.44. So Fc is 16.44 sin of 30 plus 5.74, which is equal to 9.605 kilonewton. Now last is turning moment. So turning moment, that is T. So how to calculate the value of T? So this T is, now if we observe for this crank of radius R, this is tangent to the motion of this crank. So this is the perpendicular to this crank length R. So we can say that torque T or turning moment T is equal to this Ft multiplied by R. So value of Ft is known. So we have to take here Ft is Newton. So 9605 Newton multiplied by R in meter, that is 0.2. So answer is 1921.13 Newton meter.